Shall we get started? Firstly, welcome to everyone who has tuned in live to watch and take part. I have the simple job of introducing the webinar, then we will hand over to our two expert speakers before going straight into a question and answer session to conclude. For those watching the webinar as a recording, if you have any questions, please feel free to contact me. My contact details are displayed on the screen. The Society for the Environment holds a Royal Charter, which was awarded in 2004. We are the custodian of two professional registrations, Chartered Environmentalist Register and the Registered Environmental Technician RNV Tech Register. The Society operates as an umbrella organisation, currently with 25 professional bodies acting as constituent bodies. All of these bodies currently hold a licence to award the CEnv registration to their members. 3 of these also offer the RNV Tech registration, which are now highlighted. The total number of CEnvs and RNV Techs currently adds up to nearly 7,500. This is the first part of our new 3-part webinar series, themed around innovations, the good, the bad, and the game-changing. The series will see 5 Chartered Environmentalists, CEnv speakers, explore emerging technologies and the innovations that have made a real difference to the environment. Our CEnv speakers are specialists in their field, but they will provide the perspectives from different sectors, which makes for an interesting debate. This is the format today's webinar will take. I'll very shortly be handing over to our first speaker, Brian, to start our proceedings, before handing over to Tanya. I shall introduce our speakers in a bit more detail before their talks. Our first speaker today is Brian Robinson. Brian is a Chartered Environmentalist via IMechE, the Institution of Mechanical Engineers, and runs his own consultancy business, BJR Solutions Limited, as well as leading the Low Carbon Vehicle Partnerships Commercial Vehicle Working Group. He has over 25 years' experience in transport, energy and climate change policy, sustainability, vehicle safety and programme leadership. Brian will be providing his insight into the world of electric vehicles, asking what the future holds for this exciting innovation. Over to you, Brian.
Good afternoon, everyone. Welcome to this Society for the Environment webinar on the subject of electric vehicles. My name is Brian Robinson, and I'll be describing some of the opportunities, challenges and innovations in this space, along the lines of the good, bad and game-changing theme of this webinar series. Before I begin though, I'd just like to spend a minute or two explaining who I am and the organisations I represent. I've been a freelance chartered engineer and chartered environmental professional since 2014, working via my own one-man company, BJR Solutions Limited. My technical background is in vehicle safety and environmental research at TRL, the Transport Research Laboratory, where I worked for over 15 years in total, and in energy policy and sustainability at the Institution of Mechanical Engineers. And it was during my 12 years at IMechE that I developed an interest in the environment and I became a chartered environmentalist. Since going freelance, I have maintained that interest and have been very fortunate to count as my major client the Low Carbon Vehicle Partnership, for whom I lead on various projects relating to reducing emissions from commercial vehicles, i.e. trucks and vans. The Low CVP has been around for over 15 years, is an NGO part funded by the Department for Transport and its own members, who come from a wide and diverse range of backgrounds, but are all united in helping us to accelerate the sustainable shift to low carbon vehicles and fuels. So, what's so good about electric vehicles? Well, fundamentally, they have 2 key advantages over conventional internal combustion engine vehicles, or ICEs, running on petrol or diesel. Firstly, greatly reduced greenhouse gas emissions and zero tailpipe emissions of pollutants such as oxides of nitrogen and particulate matter. There isn't time today to go into a lot of detail on these issues, and as I'm speaking to an audience largely consisting of environmental professionals, I'm sure I don't really need to. Climate change inducing emissions of greenhouse gases, most notably CO2, are still rising, and as the recent IPCC report highlighted, we now have only until 2030 to really get on top of things if we are to have any hope of limiting the effects to a 1.5 degrees C rise in global average temperatures. And as the graph here shows, the sooner we can get emissions to peak, the more gentle our transition to a zero carbon future can be. But whether we accept a 1.5 or a 2 degrees C rise, and whether we peak in 2020 or 2025, that zero carbon future has to be achieved somewhere in the 2030s or 2040s. Generally speaking, emissions from electricity production and the use of fossil fuels in buildings and industry have fallen over the last couple of decades, but emissions from transport have continued to rise. Improvements in individual vehicle fuel efficiency, and there have been substantial improvements, have been more than outweighed by increases in vehicle ownership and usage. Current ICE vehicles emit typically about 100 to 150 grams per kilometre of CO2. I'm talking about passenger cars here, while electric vehicles consuming something like 0.2 kilowatt hours per kilometre at current UK grid intensity are responsible for about 40 to 60 grams per kilometre. So a good saving, but not the 80 to 90% savings we'll need. Those sorts of savings are only possible with a much higher proportion of renewable or low carbon electricity. If, for example, by 2030 we get down to 100 grams per kilowatt hour rather than the close to 300 we're at now, as is the intention, then 80+% savings are indeed achievable. There are many players involved in the development, regulation, application and use of road transport. Almost all of them recognise the potential for EVs to be a positive part of our transition towards sustainability and are taking steps to apply pressure for that transition to be as rapid as possible. As this slide illustrates, that pressure is coming from various quarters. For example, the UK government published its Road to Zero strategy last year. The European Parliament is wanting much stricter regulations on car manufacturers, and environmental NGOs are saying it could and should all be done even faster than that. Even the motoring press are singing the praises of the latest generation of electric vehicles, with, for example, the Kia e-Niro being recently named Car of the Year 2019 by What Car. Indeed, the only concerted pushback against this do it and do it soon agenda has been by the trade bodies representing the manufacturers. They see the need for EVs, but aren't yet ready to say goodbye to the ICE vehicles their factories are geared up to supply. So how close are we to this perceived EV panacea? Well, certainly the latest generation of electric vehicle, be they battery only or plug-in hybrids, are attracting increasing numbers of car drivers. But we're still only at 3% of new car sales. So 97 out of every 100 cars bought or leased in the UK are still conventional petrol or diesel vehicles. Pretty much all of the manufacturers have plans to launch new electric vehicles over the next couple of years, though availability as of today is still quite limited. Watch out for ranges commonly in excess of 250 miles and prices comparable to ICE models. But EVs are still more expensive to buy, and manufacturers are reluctant to commit the sorts of production volumes implied by the more aggressive EU and NGO targets. EVs are not just a car thing, by the way, either. They are increasingly providing cost-effective emissions-reducing solutions in the bus, van, truck and other vehicle sectors. But are EVs really a panacea? Where are the pitfalls? Are they really the quick and painless route to environmental salvation for road transport? The short answer is no, not quite yet at any rate. In particular, I'd like to describe, over the next couple of slides, a couple of low CVP initiatives to tackle what I see as the two most important obstacles to a more rapid and widespread uptake of electric vehicles. Those are life cycle impacts and the recharging infrastructure. The usual focus with vehicle emissions has either been just on what comes out of the tailpipe, which for greenhouse gas assessments are known as tank to wheel, or sometimes factoring in the fuel production or energy generation, which are known as well to wheel. This means we have got a pretty good handle on the two central boxes in the diagram shown on the bottom right of this slide, i.e. the environmental impacts arising from when the vehicle is on the road. But we have much less information on the other impacts, particularly those from vehicle production and end-of-life disposal, recovery, reuse or recycling. Low CVP, working with member organisations such as Ricardo, have been trying to develop a clearer picture of these wider impacts and standardised methodologies for doing so. The key reason for doing this is that for EVs, a much larger proportion of their life cycle impacts stem from the production and end-of-life phases, so the traditional focus on in-use emissions is no longer appropriate. For ICE vehicles, on the other hand, vehicle use and fuel production absolutely dominate. There's much more detail available, which I don't have time now to go into, but the headline issues are that A, battery size really matters, as they have significant embedded carbon from their manufacturing, so right sizing is crucial. B, overall mileage, if very low, life cycle emissions from an EV can actually be higher than an ICE vehicle. And C, where batteries and EVs are manufactured is critical, as that affects just how much embedded carbon is within them, arising from the local grid intensity and fuel usage. Another very important thing to consider when looking at life cycle impacts is that the conclusion may vary between impacts. So what's best from a greenhouse gas emissions perspective may not be best, for example, from an air pollution, water supply, or natural resource availability perspective. This means analyses need to be holistic, and the identified best solutions may well involve a degree of compromise in some areas. The other key hurdle affecting EV uptake, in the short to medium term at least, is infrastructure, specifically where, how and at what speed to recharge them. There's a daunting array of different charging systems, many incompatible with each other, and many EV owners, especially those regularly doing quite long trips, cite charge anxiety being much more of an issue than range anxiety. At a system level, widespread EV uptake should not be a major problem, especially if smart charging is deployed effectively to exploit EVs as a way to balance out the peaks and troughs in electricity supply. The bigger issue is with local electricity networks, many of which simply could not cope if large numbers of EVs were all plugged in at the same time. Network reinforcement in the right way and in the right places is key, and that is where the low CVP and the Electric Vehicle Energy Task Force is aiming to help, bringing consumers in too. Okay, so I've outlined the goods and the not so goods of current generation electric vehicles, but what about the game-changing innovations potentially just around the corner? There are, of course, many such opportunities, and hopefully some of you will have your own ideas or even be working on them yourselves, but I'd like to highlight 4 of them today. The first relates to the batteries themselves. Lithium-ion dominates at the moment, but other options like solid-state, graphene and lithium-sulfur offer a range of advantages, including reduced life cycle environmental impacts. Second, the ways we own and use cars seems to be changing. This could mean that asset and resource utilisation is dramatically improved as we move away from the traditional, highly wasteful model of everyone owning their own car and those cars spending most of their time, that's often 22 to 23 hours per day, not doing anything. Third, the gradual move to more and more automation in vehicles could provide some positive feedback mechanisms in terms of safety and efficiency, but I do worry about their potential to make travelling by car too easy and too convenient, so much so that walkers, cyclists, bus and train passengers start choosing to go by autonomous car instead. Finally, I can't get to the end of a presentation about electric vehicles without mentioning the H word. Hydrogen fuel cells are in effect an onboard power station for electric vehicles, so recharging, refuelling becomes as easy as it is already for ICE vehicles. The major drawback, though, is that hydrogen doesn't just appear, it has to be made. That will always be very energy intensive and can be far from low carbon too. So, wrapping up, I'd conclude that there is indeed a lot to be said for EVs. They certainly have the potential to be a huge leap forward in improving the environmental sustainability of road transport, but I'm not yet prepared to call them a panacea. A mass market for EVs has to be properly planned and the hurdles addressed in ways that meet the needs of many stakeholders. The electric vehicle market expansion has to go hand in hand with the transition to smart, low-carbon electricity grids, not just here in the UK, but wherever they are manufactured too. Local action is key, not just on the part of local authorities and infrastructure providers, but also amongst local businesses and fleets. So environmentally aware and conscientious professionals, i.e. Chartered Environmentalists, aren't just needed in the EV supply chain, they are also crucial to providing on-the-ground knowledge of what will work in what application and leading the demand-side uptake of EVs amongst fleets, business users, employees and private consumers. That's it from me. Thank you for listening. Thank you for CEnv for inviting me to speak to you today, and I look forward to taking any questions you may have after our next speaker.
Thank you, Brian. I will now provide a brief introduction to our next speaker. Tanya is a Chartered Environmentalist via CEnv, the Chartered Institute of Ecology and Environmental Management, and the Environment Manager in the Planning and Environment Department at the Port of London Authority. She has worked at the Port of London for 6 years and has worked on the Thames for over 11 in previous Environment Agency roles. Tanya will provide her insight into her work to promote sustainable port operation, to improve stakeholders' understanding of the contributions to the environment by the port industry and environmental considerations of the Thames estuary. A reminder that you can ask any questions you may have via the Q&A function on your toolbar. I will pop back to ask your questions to both Brian and Tanya at the end of Tanya's talk. Over to you, Tanya.
Thank you, Sarah, and thank you for inviting me to talk about our particular strategy around air quality. A quick introduction to why an ecologist is talking about air quality. The Thames as a whole is one of the biggest ports in the UK, and the PLA has taken a view as a custodian of the Thames that we must look to improve it and return it to a better state than it has been left, mirroring a commitment in government. I'm going to talk through how we've looked at the innovation and technology may be able to help us with this particular issue we have around air quality from maritime sources. And how we in London have a specific issue that creates a challenge for technology to provide the solution. Just a quick summary of those of you who are not necessarily local and do not frequent the sides of the Thames. The Thames as a use varies massively from Teddington in the west right out to the estuary. We have a variety of uses, recreationally in the west. London centrally is focused around movement of freight for construction and for major infrastructure projects such as the Tideway Tunnel, but also as the capital city, it supports a significant tourist trade and is now emerging as a significant route for commuters to use moving across London in lieu of the transports in the trains and sides of the river. The estuary itself is more what you traditionally create the image of a port, big cargo handling facilities, lots of dredgers coming in with construction material that is then transported on smaller vessels into London. Fishing and major large container terminals throughout the estuary. So why are we interested in air quality? Well, we are part of London's emissions. The maritime source is a small one at this point in time. It's a very small amount, likely to go up over time, given that the improvements in transport, as Brian's mentioned, and technology moving much faster in the road technologies and trains over the river and maritime transport, but still only small percentages of the emissions. Different to the national emissions, domestic shipping is around 11% of the NOx in Britain inventory, and also 2% of particulates. So it's a slightly different context, but we have very different challenges up and down the estuary that it can keep moving forward. Why do we have a challenge? Because this demonstrates the difference in types of standards that the maritime engines currently, as they stand, using diesel, and unfortunately that is the status quo at this point in time. It's particularly in London. There is only one LNG vessel moving within the Thames. That's not reflective of the rest of the world, but the standards, as you can see, are very different, and the timelines to change and to improve are much, much longer. Vessels tend to last a lot longer. There are vessels working on the Thames that are pre-war, and their engines are probably slightly younger, but still not anywhere near the changeover and improvement process that you'd see on the roads. You don't tend to see the whole vessel being replaced. It may be the engine or part of the propulsion. So a lot of the challenges is around refitting. So what do we look like in the basis of that legal context, where we are emitting across the Thames? This is for the whole of the port, and the trends based on the international and UK current processes. When we looked at it in 2016, the trends looked like we would reduce NO2 as a result of a North Sea emission control area, which would benefit the Thames, which will slowly see a change of shipping and emissions from shipping, but conversely an increase in particulates and SO2. So there is a challenge for us to make some changes, to make some improvements, and to move forward and drive that forward as the Thames, particularly as the Port of London promotes the use of the Thames as a low emission alternative. It is low carbon transport. It takes hundreds of thousands of lorries off the road every year with just the normal construction and waste removal functions that exist on the Thames, and even more when you take into account the infrastructure major projects that require large amounts of materials to be transported. And yet, because of the standards, there is a concern of the emissions that are coming from the maritime sources in London. As you can see by the graph here, we have done some evidence basis of that process, and how even in air quality terms, there is a benefit to the people on the land side. So walking along the side of the Thames is definitely lower emissions than those standing past those 600 to 800,000 lorries that would have to do the same route along the roads. But how do we tackle it? We, as a Port Authority, are not necessarily able to regulate just the use of the river and the way the vessels act in the Thames over and above the national and international regulations. We can mandate certain activities, but when it comes to emissions, that was seen as part beyond our remit, lying with the Maritime and Coast Guard Agency and the IMO. And as a result, we have a number of options for us to generate interest and change and talk about how we can generate an improvement. Because one important fact I should share with you is the PLA only owns 20 of the vessels that operate in the Thames. There are hundreds of thousands of vessels moving up and down the Thames that we need to influence the owners and operators of that to change the improvements. Technology is going to be huge, but there are some challenges, and that's where the game changing starts. So here's the suite of how we're going to try and evidence the improvements, evidence change, challenge hotspots and issues and places where we need to improve, where it's having an effect on people's health, and how do we want to improve it? How much do we want to change the process, and how quickly can we engage those third-party operators to make those changes and adopt the technology? So We've set some targets as part of the evidence process, looking at the inventory and the air quality strategy and a number of actions that will take, hopefully, those curves that you saw earlier in a different direction. We've set some quite steep initial targets, given that there is no regulation to make any of these changes, and we are working very hard with the operators to make improvements, and I'll talk a few topics about. So who are we trying to influence? Well, I've mentioned the passenger transport, so the fast ferries versus the tourist vessels. They have very different profiles in how they use the Thames. It does provide some free energy in terms of the tide, and there are some operational benefits by using it. However, a fast commuter vessel can't tell its passengers that it's going to have to wait 2 hours before the tide turns into the right direction when everybody needs to get to work. So there's another solution, potentially beyond the operational changes that might be possible. Similarly, there are bridges in London, but they're in the wider estuary, it is more open, so there's different options and different opportunities. And there's also a mixed use. So we see a lot of inland craft, so the smaller vessels you can see on the slides there, I will refer to as inland craft. But then there's also the cruise ships and the larger dredgers that come into London and more in central London. Whereas out of the London area, we are talking more traditional shipping. So what solutions and how can we generate that change? We have been looking at a number of solutions. Shipping itself, it has come up with a number of solutions, and some of these are on the slide below. But how do we apply those to the London emissions? Those are principally from the inland craft within the M25. So these types of solutions, as you can see on the screen, are mostly adopted by larger shipping operators, and they are often needing quite a huge amount of space in the vessel and changes in the type of design for the ship, so significant investment in the operators. In the inland fleet, we are looking at a couple of larger fleet operators where they own a couple of vessels and run significant services, but there is a large amount of owner operators where they only own one vessel. So the type of investment required to create new solutions to reduce the emissions from their vessels is quite a challenge when you're talking about people's livelihoods. So the types of solutions I've got here is the fuel use. So there is a benefit in changing to things like biodiesel that is now available in maritime, but it is an increased cost of around 15% on operations. You could, in some cases, save some fuel use and consumption as a result, but the emissions is reduced by 20%. So a significant benefit if a lot of people adopt, and the bulk buy aspect creates a reduction in the cost. But otherwise, if it is individuals taking that plunge, then that's quite a significant cost for their solutions. There are more significant changes like LNG, Brian mentioned hydrogen. A number of technology providers are looking at that solution, but that significantly changes the operation of the vessel and the type of safety equipment they would need to carry, and the equipment and the exposure to their staff from an operational perspective. At the moment, as I said, there's only one vessel that's an LNG fueled ship that comes into the Thames. We have considered LNG as a short-term solution because of the carbon emissions, which we do not want to negatively influence. The shore power solution at the bottom of the slide is a very useful one. If the vessel is able to plug in, and Brian's mentioned the number of plugs, a lot of these vessels won't necessarily even have a plug. There is now a standard for the type of plug that would be installed from now on, but given that we may not have the power to provide for vessels, the type of power provided for big ships is going to be quite significant, and we're looking into the infrastructure that might create. Now, the Thames itself might be able to generate some green technology for us, green energy for us, but we will have to see how that technology drives forward. So looking for innovators in those sectors to come and help us create a different solution. Scrubbing is probably going to be the initial solution that will come forward for a lot of the vessels in the Thames, in the inland fleet. It can create some operational issues for existing engines and the back pressure that they experience as a result of the filtering process. And often the load will depend whether it's able to achieve it. For example, those fast ferries accelerating, slowing down on a regular basis doesn't make the scrubbing as effective as a low constant load that a tug or a passenger tourist vessel might use. But again, that saves something in the 70 to 90% for NOx, so it is a good solution if you can find the space in the engine vessels to create that benefit. In a wider field, we are looking at incentivising the operators. We already have a shipping discount for those vessels that are higher than International Maritime Organization requirements. We offer a discount on a charge that basically allows us to run the port and keep it safe for everybody. And as long as there's a network of the ports around the European continent and wider afield, then it has a significant benefit for the ships. But we are, as we are with the air quality strategy, we're the first port in the UK to adopt that. So those in domestic shipping are not seeing a benefit as yet. And in a wider context, the government has started to take action. The DEFRA's Clean Air Strategy now lists ports, UK ports, on wider field to adopt the air quality strategy approach. So we should see those starting to be published in the next couple of months once the guidance is released. And they are also looking at regulating more effectively the inland craft above the current standards, potentially extending some of the emission control zone areas beyond the east coast of the UK. Department of Transport have also looked to launch the Clean Maritime Council, and they have an innovation section called Marry UK of that. And we are very hopeful that we will see the inland vessel challenges taken into account as we go forward, so that we can find viable solutions and some good innovation to change the way the Thames operates and emits into London and the wider southeast. So we're not there yet. We're looking wider afield, being the first in the UK to do this sort of work. We're having to look at colleagues in Europe and in America. But we hope that by starting to change the way we look at emissions from maritime sources on a local level, we will start to drive the technology and improve the market solutions for the inland craft on the Thames. Thank you very much for listening. I'm happy to take questions. If Sarah, have we got any?
Many thanks to Brian and Tanya for their insight. I very much hope that those watching have found the webinar useful. If you haven't done so already, now is the time to ask a question to Brian and Tanya using the Q&A function within your toolbars. But just to go through some questions that we already have received. If we start off with one to Brian. So question here, given the accessibility problems attached to the charging of electric vehicles, how do you think that electric vehicle charging infrastructure should be rolled out within urban areas for people to charge near their homes, particularly for those with lower incomes?
Yes, thank you, and thank you to the questioner. Yeah, those are certainly important issues. Clearly, electric vehicle charging, passenger car electric vehicle charging is a completely different ball game if you don't have off-street parking and ready access to a plug, and that could be a fundamental barrier in some cases. There is lots of work. It's not really my specialist area, but there is lots of work I'm aware of going on in this space. Certainly there are projects looking at, for example, lamppost-based charging, so putting charging points in lampposts where people can park nearby. There are also some ideas around kind of mobile charging, so effectively a lorry full of batteries that can go around and go to a specific point. But clearly for EVs to be mainstream and across not just different types of houses, but the kind of social spectrum as well, then there will need to be access to rapid charging facilities easily accessible to anyone anywhere. I think that's really a key set of questions about what the policy mechanisms are to support that, that the Electric Vehicle Energy Task Force I mentioned is looking at. So watch out for its findings and conclusions coming out over the next year or so. I think the key principle here is to make sure that early adopters are rewarded where possible, and certainly not penalised, so that that the costs of developing the infrastructure necessary to charge EVs isn't unfairly borne by those who adopt EVs soon.
Thank you, Brian. In a related question, we've got, what steps can government take to ensure transport-related emissions are reduced? Brian, you obviously picked up on that a little bit there, but Tanya, do you have anything to say on that question?
Yeah, I think things like the Marry UK innovation is a good way for them to drive the improvements. And I think the balance, things like waterways are actually in some cases underused resource for transport, and can often carry more than the traditional road-based transport, because the other issue is beyond intercongestion and safety. Use of waterways is going to be a good opportunity to reduce emissions from the roads.
From my perspective, Brian here, I think the key missing, I'm an engineer, so I'm all for new technology and innovation, but I think there's a danger that we as a society, government, are too reliant on technology solutions, and I think we're fundamentally missing the key point here. It's the first layer of any sustainability hierarchy, and that's demand reduction. So I think that's, if there was a magic wand I could wave at policymakers, it would be to focus on demand reduction. That's certainly true in road transport. It's absolutely true in air transport, which one of the questioners has asked me about. So yeah, that was where I'd see, if we're missing something, that's where it is. Okay,
brilliant. Thank you both. Just a question for Tanya here. It's about going beyond road vehicles and into air and marine transport. Have you factored in these other transport modes? How do you see the timelines for encouraging moves via legislation to cover these in the total emissions equation?
I'm not sure I fully understand the question, but I'll try and answer it as best I can. I mean, ultimately, the use of the river and waterways is how we do most of our trade with international countries, and a lot of our particularly, ironically, our cars come in from through ports. So they need to be ahead of the curve, and I think we in London do a lot of work with the local councils and the planning authorities to try and factor in the use of the waterway to benefit the communities along the banks, and make the access to that resource much more feasible across society. So that's something we see a benefit that the Thames and waterway use can create.
Brilliant, thank you, Tanya. Just another question here about are hydrogen cars fuel stations safe? Brian, do you have any response to that?
Yeah, there's a couple of questions at the end there, both to do with hydrogen. Well, as safe as they can be. Clearly, safety is an issue with any fuel or energy source. So whether you're plugging in an electric vehicle at perhaps many kilowatts, or whether you're filling a conventional vehicle with a highly combustible liquid fuel like petrol, or indeed you're putting hydrogen into a fuel cell car, clearly there are ways of doing it safely, ways of doing it unsafely. Fundamental differences between with hydrogen. Yes, it's possible to do it very unsafely, but hydrogen filling stations have been around now for many years, and certain parts of the world they're now very common. Hydrogen cars are getting more and more common. For example, in Japan, and I'm not aware of any major safety issues arising. On the question about water vapor, I'm not a climate scientist. My understanding is that water vapor is only a climate forcing. Effectively a greenhouse gas if it's at very high levels in the stratosphere. So contrails from aeroplanes can have slightly odd climate forcing impacts depending on the exact altitude. But as far as I'm aware, water vapor at ground level is not a greenhouse gas at all.
Okay, brilliant, thank you. Just another question here for you, Brian. It says electric vehicle users on long distance journeys will need to wait a relatively long time for charging. How do we plan for this?
Yes, on current technology, obviously depending on how far they need to go when they've plugged in. If they've almost arrived at their destination already and they just need a quick splash, if you like, of extra power, then they don't need to wait very long. Most batteries now are talking kind of 80% charge in something like an hour if you've got access to what's called a rapid charger. But as I think one of my slides highlighted earlier, or at least alluded to, the development in batteries is moving in various directions. One, of course, is lower cost. Another is energy density, so you get more charge from a battery for a given weight. But the other is also to allow more rapid charging. So rather than charging at 50 kilowatts for 2 hours, if you can charge at 500 kilowatts for a tenth of that, 12 minutes, then that becomes much more like a conventional petrol filling station.
Okay, brilliant, thank you. Just another question for Tanya. What priority do other countries give to reducing air impacts, and locally what proportion of air impacts come from vessels? I think you touched on this briefly in the presentation, but if there's anything else you want to say on that.
Yeah, so I mean, other countries do prioritise emissions from vessels. I mentioned the European and American colleagues. So there's quite a lot of work done in European ports, Hamburg and Rotterdam, Antwerp, Gothenburg. Ports, particularly in America, are actually based and funded differently to the ones in the UK, and they are funded through the regional or national bureaus. So they are driven by those commitments to reduce. And America is very much ahead. I don't have the figures in front of me, but yes, their commitment to reduce emissions is much faster, much harder. They institute a lot of activities, so things like the air quality strategy, and the discount I mentioned earlier has been in place for a number of years, and they're able to go back over inventories at intervals to see the improvements that has made. They are still, as we are here, dealing with international shipping, so there is a limit to how much control they have over the activities. But certainly in the European ports, they are being driven by both local and national governments to try and reduce their emissions.
Okay, brilliant, thank you. Just a question for both of you. What innovative technologies should developers be considering to ensure homes and offices are adequate for future communities? Brian, you wanted to start on that one?
Yes, okay. I'm not sure if the question is talking specifically about transport or wider impacts around buildings, but I guess from a transport point of view, it's down to the basics of proper planning and locating things that people need near to where they live. And if you can't do that, then making sure there are good low carbon, low emission forms of transport to ferry people from one place to the other. I guess looking outside of the transport sphere for a minute, the basics, going back to my energy policy days, is around just building proper buildings with decent insulation standards that actually comply with building regulations and enhanced building standards. They've been doing this for decades in Scandinavia, but we still can't seem to do it here. So let's get on with it.
Brilliant, thank you. Tanya, do you have anything to say on that one?
I mean, the only thing I'd say is it's strategic planning. There are opportunities beyond the building of a house where the infrastructure comes in with different power supply. I know there are infrastructure projects in London and on the Thames that need extra power in order to deliver, and that power being brought into a town or a urban area to allow for extra power for the transport at low emissions would be a good legacy to consider. So it's not so much the technology itself, it's looking in the life cycle of projects, and many projects look at legacy, but sometimes that opportunity seems to be missed, and those grid connections are taken away, closed down after the major project has finished, when they could actually be very beneficial to the communities nearby.
Brilliant, thank you. A further question to Brian. Should there be a move to standardised charging types for electric vehicles?
Yes, thank you. I mean, the simple answer is yes, probably. I don't think it's helpful to have a myriad of different charging systems and therefore different wires and charging points all basically in the same place to cover all the different options. Again, I guess that's part of the issue would be for the Electric Vehicle Energy Task Force. That's a UK focus. We've managed to get this far without mentioning the dreaded B word, so I'll mention Europe, of course. These things probably need to come from a European level. It's about getting the manufacturers and the infrastructure providers to agree on a common set of standards, so that whether you've got a Tesla or a Renault or a Ford or whatever, you can arrive at a charge point and plug it in.
Brilliant, thank you. Just a further question for Tanya. Someone's asked about alternative fuels and the pipeline for port traffic.
Yes, so they're not that different from what we've talked about on the roads, and Brian's mentioned a few. I mean, electrification is probably a little bit further away than we are on the roads. There is use of LNG and hydrogen. Electrification is possible in some cases where short journeys. There's some cases over in Holland and the Baltic states where they, if their vessels are moving short distances, come back to charge while they transfer their cargo or passengers, and so on. There are also wind. I didn't focus on that particular picture in the slide, but there is the additional power of the wind, and there's lots of innovation around how to effectively make ships sail, literally. But for us in the Thames with the bridges, that does create a limiting factor as to where that's applicable. There is also a emerging story around the sort of hydrogen and air cushioning of vessels, so they are effectively using the water they're in and making themselves more efficient moving through the water. So often it isn't necessarily about different types of fuel, it's different design to make them more efficient.
Brilliant, thank you.
Sarah, there was a question earlier from David Watson about hydrogen and linking hydrogen to nuclear power. I'm happy to pick up if David's still listening. Yeah, understanding is hydrogen production is only efficient at high temperatures. That may well be true. I'm not a hydrogen production chemical engineer. There's two ways of producing hydrogen that I'm aware of. One is by steam reformation of methane, i.e. natural gas. So that's a high carbon source, which then, yes, I'm prepared to accept. It's quite likely that the higher the temperature of the steam, the more efficient that process would be. So having a source of high temperature steam, i.e. a nuclear power station, would be a more efficient way of doing it than a lower temperature source of steam. The other way is via electrolysis, which just uses electricity and turns H2O into hydrogen and oxygen, and therefore where the electricity comes from doesn't really make any difference. The problem, of course, with nuclear power is that there isn't very much of it, and what we've got is shutting down, and the new ones are not going to be are going to be a bit few and far between, and going to take years and decades and lots of money to build. So I don't think nuclear is a key part of the hydrogen economy, though it could play a part. And the point of electrolysis really is around essentially renewables, particularly intermittent renewables, have a bit of an advantage over nuclear when it comes to hydrogen production, because when they're generating electricity that isn't needed, they can be producing hydrogen, which can then help to balance out the peaks and troughs. So there's actually quite a nice business case around using renewables to generate hydrogen and turning it back to electricity when it's needed. Although I should also point out that the energy losses in the hydrogen system aren't just limited to its production. It's got to be distributed and stored, and in the case of a fuel cell, it's got to be purified, and all of those involve losses of energy along the way.
Brilliant, thank you very much. We just have a couple more minutes if anybody has any more questions to ask. Otherwise, I think Tanya, I didn't know if you had anything else to say about generally how you see the future for controlling ship and port emissions. Anything you wanted to add to what you've already said?
No, not particularly. I mean, ultimately, I would, to the participants, say if you've got any innovative solutions, I think there is a need to drive that technology forward. So more of call to arms than any solutions. Okay,
and just a question here about how much better is biodiesel than normal diesel in terms of particulate and CO2? What impact does its production have on land use? Is it grown in areas where rainforest has been cleared?
Yeah, I'm happy to pick that up. Yeah, the key point is not all biodiesels are the same. They don't all come from the same place. So yes, in the early days, biodiesel was coming from frankly unsustainable sources. There has been much work over the recent years to develop sustainability standards for all forms of biofuels, and those have resulted in some major improvements, I think, in the supply chain for various different sorts of biodiesel. I know the Low Carbon Vehicle Partnership is working with organisations such as the Renewable Energy Association on enhanced sustainability standards for what's called advanced biofuels. So those are largely waste derived or other more sustainably sourced forms of biofuels. In terms of tailpipe pollution, biofuels, alternative fuels don't have a major impact with modern engines. But obviously with this, there is a big CO2 benefit if you're not using a fossil source of carbon. If you're using a bio source or a synthetic source of carbon, then there will be a big well-to-wheel CO2 saving.
Brilliant, thank you, Brian. So we need to wrap up now. So a huge thank you to both Brian and Tanya. Thank you for all of your questions. Just a few other things to tell you about before we finish. If you are interested to hear more of our webinars, you can find the recordings of previous series on becoming a CEnv or R&B tech and waste reduction on our website. They are available on the Society for the Environment's YouTube channel as well. As mentioned at the start of the webinar, we have 2 more webinars in this 3-part series based on the topic of innovations. The next webinar will take place on the 28th of March and will explore innovative technology as a solution to climate change, followed by the last of the series on the 4th of April, focused on the role of sport as a driver of innovation. To add to this, our next webinar series, due in mid-2019, will be themed around a sustainable built environment. We are currently looking for CEnv and R&B tech speakers for this next series, so please do get in touch if you are interested or if you'd like to nominate a relevant person in your network. Lastly, we are currently running a survey of environmental professionals. If you are a Chartered Environmentalist or Registered Environmental Technician, please complete the survey via our website, which is socenv.org.uk/insight, and help us highlight the value of registrants to employers and decision makers. The survey takes around 10 minutes to complete, and we are grateful for any time you can give in contributing. So, thank you once again to our speakers and to you all for listening and taking part. We look forward to seeing you at the next webinar. Thank you very much.